Today we'll be doing notes for 1.3c, solving and graphing intersection inequalities. These are the types of problems you're going to see in level 4 on the test. A compound inequality is when the solutions lie between two quantities. So when you see an inequality written like this, it means x is greater than 1 and x is less than 3. You may also see it written like this. They mean the same thing. When two inequalities are joined by the word and, both statements must be true at the same time. So for example, we have -6 is less than -3x is less than 18. We would interpret this as 6 is less than -3 and -3x is less than 18. So in order to solve this for x, we need to solve each inequality separately. So we would take this half and solve it, and then you'd also take this half and solve it. So let's solve -6 is less than -3x first. So to solve this, I need to divide by the coefficient. I'm dividing by a negative number, so I have to flip that inequality symbol. And now I have +2 is greater than x. I'm going to rewrite this so that x is on the left. Make sure that your inequality still points at the x when you turn it around. Otherwise, you're changing the meaning. So now I will graph this. X is less than 2, has an open circle, sorry for that pause, has an open circle with an arrow pointing left. Let's solve -3x is less than 18, the other half of this inequality. I'll divide by -3. Again, dividing by a negative number, I have to flip the inequality symbol. So now I have x is greater than -6. Since my x is on the left, I can go ahead and graph this as is. So I have an open circle at -6 with an arrow pointing right. The solution to the and compound inequality is the intersection of the solutions of each inequality. In other words, if we took the pink graph and the green graph and we put them together on the same graph, where they overlap is the solution. So we're going to rewrite the inequality with the x in the middle and make sure that the inequality symbol flips if you move the x to the other side. So this is what I mean. We're going to take these two solutions we found above and rewrite it with x in the middle. So I'm going to put x in the middle, and then I want to write it least to greatest. So I will put -6 on the left and +2 on the right. Let me use the colors that I was using, -6 and +2. Now I need to go back and look at the inequality symbols. Was it pointing at the x or was it pointing at the number? For x is less than 2, I'm going to put the symbol here. And for x is greater than -6, I will put the symbol pointing that direction. So if you see above right here, the inequality is pointing, if you think of it as an arrow, is pointing at the -6, and down here it is still doing the same thing. And then for interval notation, I have inside parentheses -6 and +2. Now I can graph this on my number line, where I have an open circle at -6 and I have an open circle at +2. And then a line connecting them. So all the numbers between -6 and +2 are the solutions for x. Let's go over some more examples. So first I'm going to kind of divide this. And I'm going to solve two separate problems. I'm going to solve 54 is greater than 9x, and I'll solve 9x is greater than 18. So on the left side, I will divide by 9, and I end up with 6 is greater than x. For now, I'm going to leave it like that. I should move the x to the left, but for now, I'm just going to leave it like that because our final answer will be written differently. On the right side, divide by 9, and you have x is greater than 2. So let's write the inequality notation. I need to write these numbers least to greatest with x in the middle. So I'm going to put 2 on the left because remember we want it least to greatest. And I'll put x in the middle and 6 on the right. Now I just make sure that my inequality symbol still points at the same thing. So here we have between the 6 and the x, the arrow points at the x. So I'm going to make sure that the arrow still points at x. Still points at x. And then for x is greater than 2, I need to make sure it still says that here. My inequality is pointing at the 2. So still points at 2. So my inequality notation is 2 is less than x is less than 6. My interval notation will be parentheses 2, 6. And the graph of this compound inequality will be an open circle at 6, an open circle at 2, with a line connecting them. Number 2. This one is written differently. It doesn't have 3 terms with inequality symbols between them. It says 4 minus x is greater than or equal to -5, and 8 plus 10x is greater than -32. So I do this the same way, where I'm going to solve each inequality separately. 4 minus x is greater than or equal to -5. 8 plus 10x is greater than -32. I just copied those down. Now I can solve this. So I would subtract 4, bring down -x is greater than or equal to -9. Remember there's a 1 here, so I would divide by -1. And I divided by a negative number. I have to flip the sign. Now it's less than or equal to +9. And on the right side, subtract 8. 10x is greater than -40. Divide by 10. I do not need to flip the symbol because I'm dividing by a positive number this time. So x is greater than -4. So now I will rewrite these least to greatest. So -4 goes on the left, x in the middle, and positive 9 on the right. And when I write in my inequalities, I just make sure that they're still pointing at the same letter or number. So here's a hint. If you always write the numbers in order from least to greatest, you're always going to have less than or equal to symbols. They're always going to point left. So my inequality notation is -4 is less than x is less than or equal to 9. Interval notation, parentheses, -4, and then 9 with a bracket. And when I graph this, I have a closed circle on 9 and an open circle on -4. Number 3. 21 is less than or equal to 3x plus 9 is less than or equal to 33. So here's my compound inequality. I'm going to be using 3x plus 9 twice. So I'll use it here. 21 is less than or equal to 3x plus 9. And then on the right, I'll have 3x plus 9 is less than or equal to 33. Solve it both ways. Subtract 9. 12 is less than or equal to 3x. Divide by 3. 4 is less than or equal to x. On the right, subtract 9. 3x is less than or equal to 24. Divide by 3. I do not need to switch the inequality because it is being divided by a positive number, so I get x is less than or equal to 8. Rewrite it least to greatest. So 4 on the left, x in the middle, 8 on the right, and I'll have less than or equal to here and less than or equal to here. Brackets for 8 for my interval notation. Closed circles on 4 and 8 with a line between them. Last example. Set up your two inequalities. -30 is less than or equal to -2x minus 10, and -2x minus 10 is less than -26. I'm going to add 10. -20 is less than or equal to -2x. Divide by -2. Now I'm dividing by a negative number, so I have to flip the symbol. And I have positive 10 is greater than or equal to x. On the right, add 10. -2x is less than -16. Divide by -2. Again, I have to flip that sign. X is greater than positive 8. Okay, so I'm going to write my numbers in order least to greatest with x in the middle. 8 goes on the left, x in the middle, 10 on the right. And then I will have a less than sign between 8 and x, and a less than or equal to sign between x and 10. Interval notation would be parentheses 8 and then 10 bracket. Closed circle on the 10, open circle on 8.